Hello and welcome to TruePath and op5's webinar with the topic Distributed Monitoring using op5 monitoring software. Today's presentation is made by Fredrik Åkerström at op5 and Douglas Mauro from op5 professional partner TruePath Technologies Inc. So I hand over to Douglas to do the presentation. Welcome, Douglas.
Thank you, Fredrik. Looking forward to this presentation. Again, Douglas Mauro, founder and senior engineer here at TruePath Technologies. We've been around for a little over 10 years. Author of the O'Reilly SNMP book. Been using op5 and partner for a long time. We absolutely love it. And we're very happy to be a part of this webinar, so thank you. Today's discussion is distributed environments. And let's first talk about why have redundant monitoring. Why do we want to go above and beyond a single instance that's sitting out there in our environment? And the answers are pretty easy. We want to have little to no monitoring downtime. We don't want to have our monitoring system go down. More companies are relying on it more heavily. And when that single instance goes down, you don't get the insight or the analytics and the reports and the notifications that the businesses are really counting on. Let's talk a little bit about upgrades. If you have a single server, the upgrades mean that at some point you're going to have to take the system down. And when you have redundancy, you can fail the checks and the reporting and whatnot over to the other and be able to keep the system up and running. The load balancing from a growth standpoint is nice because you have the ability to share the load across multiple servers, multiple masters, multiple peers. And the really excellent thing with the op5 monitoring software and the distributed piece is that you can do that on the fly. Hardware failures, you'll be able to fail that. It automatically fails it over. These are not the old days of the Sun cluster, Veritas cluster, where you had these quorum devices and these intricate setups, and you really had to work to get it to really do what you wanted to do. Out of the box, the op5 monitoring, distributed monitoring, is set up to do just that. They just want to be able to share the load. If one fails over, the other one works very hard to take everything over to it. And when you fix the other node, whether it's the second, third, or fourth node, it'll slosh all of those checks back over. So the administration is very easy. Redundant monitoring means that you're going to have notifications constantly flowing. You're not going to lose that alerts and notifications because of a single point of failure. And more departments can depend on the tool. Again, the monitoring is starting to rise up into the stack as far as what people really rely on. So when you have that, you need redundant monitoring so things don't go down. So let's talk a little bit about the difference between distributed monitoring and load balanced monitoring. So distributed monitoring means that you have sort of the top machine here, which we're going to call the master, and you have these remote pollers. Now these pollers can be thought of as sort of self-contained units. So we have the master sitting in New York, and on the other side of the country we may have a poller. And what's nice about that is we may have a small connection to the poller, but the poller is doing sort of all the hard work locally within its site, and it's reporting back only the important information. Connectivity is lost if you have an unreliable connection between the poller and the master. Once that's restored, the poller master will resync what's been going on since last communication and continue steady state from there. Each poller has their own host group, so you can set that up nicely so that the California poller is only talking to the California host group. You have your Spain poller only talking with the hosts that are in Spain, and so on. All the configuration, all of the distributed parts and whatnot, configs are done on the master web-based interface. Set up with the VPN and SSL for secure tunnels. You can even performing the monitoring behind separate NAT environments. So that's distributed monitoring. Now, you'll see that there's no, while while there is a little bit of load sharing in the sense of you have the polars sort of doing the hard work, there's no load sharing on the master side. And when we get into that discussion, here's the load balancing piece. And so you can see these words peers, think of them in a sense as you have three masters all working together. And if you have 100 checks, each of those are going to have 33%, or just about 33 checks. And again, how do you do that? It's auto magically done, and I'm going to show you that in the demo coming up. Once you have a single peer, you add the next peer, it balances it across there. The next one balances it in thirds, and so on. You can look at the configs and reporting on any of the peers. All of the peers are the same configuration. And again, you can keep growing this thing out. The more peers, high availability, and there's totally dynamic active check distribution. And we can show it on the fly as well within the demo. So let's look at some example deployments. Let's look at what might be a typical deployment for some load balance. So we have a master server sitting in a particular site, and that master server might actually be monitoring things locally. The checks are performed through a NAT firewall, through SSL, in site B on the bottom left. And on the bottom right, you can see that we have another firewall with SSL in polar site C. Now the cool thing is the firewall only needs to open up 443. And any checks that are not assigned to any of the polars are actually performed by the peer or the master. So you can get some pretty intricate pollings going back and forth, but this is a nice example of how you might have one data center monitoring its local nodes and two remote sites through a NAT firewall monitoring their sites, both B and C. Here's load balance with the remote polars. Again, in this case, we have two masters or two peers at the top, and they're communicating to two different locations, bottom left and the bottom right, where you have a distributed load for the polars on the site A, let's call it, and then you have another on site B. And again, the polars are the ones that are responsible for performing the checks on the remote distance side. And the masters and peers, even when they're load balanced, can still perform local checks if need be. So what I'm going to do now is I'm going to switch to some active examples. We're going to be taking a look at an active peer. Well, first, it's pretty neat because we're going to set up we're going to start with a master, and then we're going to add a peer to it. And we're going to do it by the CLI. Then we can actually stop or fail that one and then see how that looks. Then the next thing we're going to do is we're going to set up a remote polar onto one of peers. So I'm going to try to switch over to my desktop here. And I believe, correct me if I'm wrong, that you can see this screen. Is that correct?
That's correct. We see the screen.
Wonderful. Okay, so I'm using Chrome here, and we have it zoomed in a little bit so everybody can see it. I'm actually logged into Peer 1. And what we're going to do is I have Peer 1 and Peer 2 sitting here. And what I'm going to do is just issue the command monnode status. And you'll see that I have 2 hosts and 82 service checks. It gives some additional information of uptime, host checks, service checks, handled, expired, total, and all that good stuff. And over here with Peer 2, if I were to do that, you'll see that we have, well, actually, this is set up from, this is from an old settings here. So we're going to ignore that for a second. What I do want to show you here is on the Peer 1, you can see that we have only one system in here. So it has the 2 hosts and the 82 service checks. So what I'm going to do is I'm going to run the command on here, monnode add peer 2. That's the command. I'm going to look that up for a second. So it's telling the that we want to add the node peer 2 as the type peer, and we've successfully added it. And it's funny, that's how easy it is. One of the things that we can do as well is we can fetch the keys. So here's where we're going to push all the keys out to the appropriate servers. Now, they're already installed. We're going to fetch the keys so that we can communicate nicely, and we already have all those keys. And now we're going to remotely control peer 2. So you notice with this command, I said monnode control peer 2, and we're going to tell that to add peer 1. So if you will, I'm going to sort of magically be typing these commands over in this window remotely through peer 1. And so you'll see that by this remote output start, remote output done. So I'm executing these commands, and we've successfully added peer node 1. So that's coming from this guy over here. Then what I'm going to do is I'm going to restart the processes for this so that they both are all in sync. And you might spot a yellow line going by. I'd be very surprised if you did, but basically it is the remote output from the peer 2. So whether it was 1, 2, 3, 5 of these peers, it would take care of it for you. Let's go back here and take a look, and magically we now have our second peer sitting up there. So what we're seeing here is the number of checks and hosts, and you'll see, look, it's magically already gone through and spread the load across. And as it starts banging out the service checks, you'll see that it'll start increasing this number for the S, or the service checks that it's done. And a lot of times people ask us, well, what else do we have to do? That's it. That's all you have to do. That's the great thing. You set this up, you set up a load balanced, distributed environment with just a few commands. So it's very easy to do, just as easy to do on the far side. If we go over to, if I do a stop on this thing, which basically is, bringing it to its knees, you'll see on this side that if we look at the status, it's inactive. So we've lost it. Now this thing doesn't know why it's come down, but it will work very hard to move this back to itself. So if we had to do downtime, if we wanted to do patches, if we want to do anything over there, very easy to do. Take it down, reboot it, do whatever you want, and when you're ready, start it back up and it'll load balance over there. So easy to do. I'm going to go ahead and close these now so I don't confuse myself. Those are the peers, and what I'm going to do now is switch to the next section, which is the remote polar. So we're going to start like we did before. We have one system, 3 hosts, 123 checks. Look at the master. Let's take a look at the status, see what it looks like. Looks good. What I'm going to do now is I'm going to fire off the command monnode add polar, and the type is a polar, and the host group is polar 1. So what we're doing here is we're saying for that host, for that polar host, I want it to be in charge of the host group polar 1. Let's take a look. Let's go up to the host group, and let's see what the Polar 1 host group looks like. So if I go into Polar 1, guess what? It has 2 devices in there with 82 service checks sitting in there. So that's what it's looking like. So I'm telling this server, hey, I want to add a remote Polar, and it's going to be in charge of Polar 1. And there we go, easy as pie. Now the other thing, and I'll just skip this for now, is pushing and fetching the keys. But I'm going to run a couple more commands here, where I'm going to, again, like we did before, I'm going to tell the remote side, hey, you have to add me, as the master. So I'm telling the remote Polar, add me as the master. And we're going to update some of the configuration files as well. So I'm going to go here, issue some of the commands, and comp files, and then we're going to go ahead and push it. And from there, like we did before, we're going to issue a restart on Mon, and we should see this come up. So a little bit more about those configuration commands. I sort of waved my hand over there. Those are the configuration files that really tell it what host groups it should be monitoring, all within one simple file. And those are the OComp files. And so we're going to sort of create those comp files and push those comp files over. And now if we go up into here and we go back to the tactical overview, you can see that we now have a Polar and our main device. And guess what? This thing is starting to check as we thought. So really easy to do, quick setup. I'm going to go back to the status and show you how we now can see how we have our local machine and we have our Polar called Polar. It's active. We've seen it alive 3 seconds ago. It's supposed to be checking 2 hosts, and it has. It's supposed to be checking 82, and it's gotten through about 9 now. And you'll see as we go through, that'll keep climbing up and up. So whether it's distributed monitoring, whether it's load balanced, you can see how quickly it is. And the other thing to note is, as I move around on the screen, I didn't really have to do anything on the remote sides. So if you're physically not located, or you might not have that sort of access, or really just from a scripting standpoint, you can do this all from the main peer or the main master servers. So let's go ahead. I'm going to switch back here. I'm going to do stop screen sharing. And we're going to go back to the slides here. And we'll switch to the next slide, which is our customer case. So I just want to say that Giant Eagle is a great company in the United States, very large grocery store chain with over 400 stores. They've been a real joy to work with. They have a great infrastructure and a great team, and they moved to op5 because of the features, the functionalities, getting those enterprise grade features, without having to pay the huge dollars of some of the top 3 name brands that are out there. They are using load balancing, and it is working very nice. And they came off a system that just didn't scale. And so we're starting to see some huge numbers of tens and hundreds and thousands of service checks. And this is a great case because when you step back and you look at their infrastructure and the size, they want to keep growing. And this software allows them to do that, specifically because of the distributed and load balanced environment that op5 provides. What I'm going to do now is I'm going to hand this over. This is a diagram from a live setup that op5 has. So I'm going to hand this back over to Fredrik, and he's going to talk a little bit about this slide.
Okay, thank you, Douglas. I will try to explain how we use distributed monitoring to release a new service that op5 just released to the market. It's called op5 Live. It's a cloud-based monitoring where end customers can go into the system and just add services, for example, monitoring home pages. What we can see here is a diagram. If we start at the top, we have a web interface. It could be tablets like iPad or iPhone, Android phones, web interfaces that is connected to a front application that we see in the middle, which is database and front application connected to a monitoring platform. One monitoring platform is based in US and one in Europe, and it's a load balancing we're using there. And of course, we are pushing the people from each tablet or web interface to the right peer in this case. Next challenge is that we have a customer now logging into a different location, and they want to monitoring different web pages all over the world. So now we have to distribute the monitoring by some help from the pollers, and the poller is down to the left. We now have pollers in all over the world that is based either in the Amazon or in the open cloud, where we could monitoring, for example, a server in Paris from the poller in Paris, or a web shop in New York from the poller in the New York area. And at the same time, we also monitoring free external services, which is Stripe, which is a card payment tool, the CRM system, which is Salesforce in this case, and SendGrid, which is a notification and alarm tool. But with using the distributed setup here with pollers and redundant masters, we now could push monitoring to each local area in the world. So I hope that explained a little bit how, with this picture, how we do it.
That sounds great, Fredrik. Yeah, thank you. I know that we're running a little bit on time and there's a few questions, but I think what we're going to do is we're going to follow up with an email and put some of the answers to the questions that we currently have out there. I think for now, what I'd like to do is just say thank you to everybody that's here. Thank you to op5. And just say that we've been a long-term partner with op5. We've absolutely loved the interaction with not only the people that we work there, but from a sales and a management perspective, but also the engineering. We've been using the Nagios software for a long, long time. TruePath's been around for over a decade, and op5 has really taken that product and made it an enterprise-grade product that customers truly appreciate and enjoy using. It's an excellent product, excellent support and software. There's live demos on there. And as one of the premier partners in North and South America, you can always reach out to us. And again, just say thank you.
Okay, thank you from Fredrik here too, and welcome back to next webinar.